is a subspace. Prove that intersection of two subspaces of a vector space is a subspace. So what is supposed to prove here? You have to prove that intersection of two subspaces is again going to be a subspace. So what is the condition for subspace? It should be non-empty. And what is the second condition? Alpha x plus beta y belongs to the set. Okay, then we can prove that it is a subspace. Here what you are supposed to prove? Intersection. What is the meaning of intersection? Common. It finds the common elements. Okay, so start with the proof. Proof. Let second is A. Let W1 and W2 and W2 be two subspaces of a vector space V over a field F. Vector space V over a field F. Right? To prove W1 intersection W2 intersection. To prove W1 intersection W2 yes a subspace of V. Okay. Now what you have to prove? Intersection is going to be a subspace. So you have to prove that this intersection is going to be a non-empty set. And it will show that alpha x plus beta y should belong to this intersection. Before going to that one, tell me what are the conditions given for you already now. What is the condition given? What is the condition? What is the condition given? Assumption. What is the assumption you made my first step? And alpha x plus beta y belongs to W1. 0 belongs to W1. Alpha x plus beta y belongs to W1. So right. Next one. Since W2 is a subspace. 0 belongs to W2 and alpha x plus beta y belongs to W2. Alpha x plus beta y belongs to W2. Therefore, 0 belongs to W1 intersection W2 and alpha x plus beta y belongs to W1 intersection W2. So what is the conclusion you can take? W1 intersection W2 is a subspace of V. So that takes W1 intersection W2 is a subspace of a vector space V. Okay. Now we are told that intersection of two subspaces is going to be a subspace, but union it is not so much. Generally, we can't give any statement that union of two subspaces is going to be a subspace. Only in few cases it will hold good. In some cases it may fail also. We can't give a generalized result for union. Okay, the result holds good only for the intersection. Okay, like this you can extend for any number of subspaces also. Okay, so we can extend next one. Next result. Prove that union of two subspaces of a vector space need not be a subspace. Need not be a Union of two subspaces of a vector space need not be a subspace. Okay, it is a generalized statement now. As I told you already, we can't do it in general for this one. Because in some cases it can be a subspace, in some cases it cannot be a subspace. So how we are going to give the proof is that we are going to define two different sets. And then from that we are going to prove that the union is not going to be a subspace. Okay, now the generalized statement of whole organ. Okay, yes. ஏதாவது ஒரு rare case it may become as a subspace also. அதனால இந்த proof கொடுக்கிறதுக்காக நம்ம என்ன பண்ண போறோம்னா நம்மள ஒரு ரெண்டு செட்டை டிஃபைன் பண்ணி அந்த யூனியன் வந்து சப்ஸ்பேஸா இருக்காதுங்கறதை உங்களுக்கு தெரியும். Okay, so start the proof. Let W1 is equal to the set of all elements of the form A00 such that A belongs to R. We define W1 like this. And W2 is equal to the set of all elements of the form 0B0 such that B belongs to R. Such that B belongs to R. Okay. So whether these two are subspaces, no? Whether these two are subspaces, there is already put a similar result. Whether it is non-empty or not? What is the non-empty element? 0, 0, 0. 0, 0, 0 will become as a non-empty element. And alpha x plus beta y, if you check means what you will get? A0, 0, A1, 0, 0, A2, 0, 0. Whether the combination will belong to W or not? Second condition satisfy or not? In a condition you have alpha into A1, 0, 0 plus beta into A2, 0, 0. What is the resultant answer? Alpha A1 plus beta A2, 0, 0. Whether this belongs to W1 or not? Yes or no? What is the nature of W1? Y and Z should be 0. Only should have the element only in the x coordinate. Whether it is satisfied or not? It is having that element only in the x coordinate. What about Y and Z? Same. Whether the condition is satisfied or not? Yes or no? So it belongs to W1. Whether W2 will be a subspace? Yes or no? What is the non-empty element? 0, 0, 0. B can be 0. Whether alpha x plus beta y belongs to W2? Yes or no? Other element எப்படி இருக்கும்? Which two should be 0? X and Z should be 0. We should have value only in the y coordinate. Whether it is satisfied or not? Yes. So obviously W1 and W2 are subspaces. So right. Clearly W1 and W2 are subspaces of V. Subspaces of V. Now what you are supposed to prove? You have to prove that the union is not going to be a subspace. So for that you are going to assume two elements, one element in W1 and one element in W2. So right, we have 0, 1, 0 belongs to W1 and 1, 0, 0 belongs to W1 and 0, 1, 0 belongs to W2. 0, 1, 0 belongs to W2. Okay, so add both. What you will get? Add both. Just directly add 1, 0. Whether it belongs to W1 union W2? 1. Yes. When you add both, what you are going to get? 1, 1, 0. Just scalar addition and check. Okay, addition and multiplication satisfy other conditions satisfy. This addition is satisfy. Just we simply add both the elements. What you are going to get? 1, 1, 0. Whether it belongs to W1 union W2. Yes means give the reason, no means give the reason. Whether it belongs to the union of both, no? Yes. Why? Both the 1.0 that does not belongs to W1 union W2. So normal addition itself is not satisfied. So right, hence W1 union W2 union W2 is not a subspace of E. W1 union W2 is not a subspace of B. Okay, even if you forget also no issues, ma. You assume any two sets to be like this and you give the proof. Okay, here just for understanding you assume the values to be 1. Even if you give the proof with the same A and B also. If you assume the elements as A and B, what happen? When you add both, what you will get? A, B, C. Whether it belongs to W1 union W2? No, obviously. Okay, this set மறந்தாலும் பிரச்சனை கிடையாது. இந்த condition satisfy ஆகும்போது நீங்க இங்க எப்படி வேணாலும் டிஃபைன் பண்ணலாம். Okay, you make any two coordinates as 0 and one coordinate will having the element. You can change it to any two coordinates also. Obviously, it will not become as a subspace. Okay, any doubt, ma'am? Yes. So, what is the first topic we completed? Vector space. Then we discussed about the vector subspace. So, as usual, why we are discussing algebra? Already in the first class I told you. What is the applications? What is the main application I told you? Solving system of linear equations. That is our main objective for algebra. Okay, even though we have many methods of solving system of equations, in some cases that may not work out. So one of the applications of algebra will be solving system of equations. For that one we are studying all the algebra concepts as in basic. Okay, so next it will be like a problem for 2 or 3 classes. It will be easy for you. Okay, so before going to the linear transformation or other things, first you should know what is the direct sum. Okay, how to add it. This is normal addition. We are going to define 2 more addition. One will be called as the direct sum. How to combine and define the direct sum, we are going to define it. After that, we will go for problems where we are going to solve simultaneous equations. Just I will complete that this one. ECA, this be Abhishek present, right? Adityan, Ajay, Arun Kumar. Girls, action is Nyanna Surya.
Abhishek
present. Ashwin, ma'am. Bennett present. Deepan. Davidaran. Gautam. Hariharan. N. Hariharan. Kemakpar. Hey, udah sudah. Kemakpar present. Jagdish. Kaviran. Kavi Mukesh. Girls, full marks in jalan. A. Darshini. M. Gayatri. Sarabiri. Kayaravan. Eunice. Okay, continue. So just we are going to define 2 more additions. After that we are going for solving simultaneous equations. That will like a problem solving. It will not be like theoretical part as we discussed so far. Okay, so take down that linear sum of 2 subspaces. Linear sum of definition, linear sum of 2 subspaces. Linear sum of 2 subspaces. So right, let W1 and W2, let W1 and W2 be 2 subspaces, of a vector space V. Of a vector space V. Then the linear sum is defined as W1 plus W2 is equal to W1 plus W2 is equal such that small b is equal to W1 plus W2, small b equal to W1 plus W2, such that W1 belongs to capital W1, small W2 belongs to capital W2. This is called as a linear sum. One element from W1 and one element from W2. Next one, direct sum. Direct sum of two subspaces. Next definition, direct sum of two subspaces. Same statement, no? Take W1 and W2. Take W1 and W2 be subspaces. Be subspaces of a vector space V. Of a vector space V. Then G is called vector space V. Then V is called a direct sum. V is called the direct sum of W1 and W2. Of W1 and W2 if W1 plus W2 equal to V. First condition, W1 plus W2 should be equal to V. Second one, W1 intersection W2 equal to the singleton set 0. Equal to the singleton set 0. Like this line. If V is a direct sum, if V is a direct sum of W1 and W2, then V is equal to W1. The notation symbol for direct sum is that you have to put a plus and put a circle. The meaning of this one is direct sum. W1 plus W2. Okay, have you come across this symbol or not?
Yes, ma'am.
So that is called as the direct sum. General addition is called as the linear sum. If it is going to be a direct sum, what are the conditions should be satisfied? What is the first one? W1 plus W2 should be equal to the vector space V. And W1 intersection W2 should be equal to the singleton set element 0. What is 0, ma? Non-negative. What is actually 0? Meaning of symbol 0? Additive identity. 0 is nothing but our additive identity. Okay. So just to discuss a small problem based on direct sum, then we will go for our system of equations. So take a problem. Show that M2 of R. Tell me what is M2 of R? What is the meaning of the symbol? Say so. 2 cross 2 matrix. 2 by 2 matrix. 2 rows and 2 columns. What is the meaning of R? Yes. So all the elements in the matrices is going to be a real numbers. That is what we write as M2 of R. So right? Show that M2 of R is a direct sum of W1 is a direct sum of W1 which is equal to defined as the elements of the form AP00 such that AP belongs to R. This is how you define W1. Similarly, W2 equal to the matrix of the form 0, 0, CD such that C, D belongs to R. are the conditions, no? W1 plus W2. Say over. Equal to V. The linear sum, no? The direct sum. I gave you all conditions. What are the conditions? W1 plus W2 should be equal to the single constant 0. The corresponding additive value should be in the set. Okay, what is the next one? Intersection. First condition is over. Where is the other one? Non-empty and it should be equal to B. Okay, as well as முன்னாடி ஒரு important condition இருக்கு. இது ரெண்டு conditions சொன்னேன். பட் ஒரு மேஜர் ஒரு விஷயம் இருக்கு அதுல. அதெல்லாம் நோட் பண்ண வேண்டியது. Yes, very good. So before checking the direct sum, what is the basic thing we have to check? Whether W1 and W2 are subspaces. Only if W1 and W2 are subspaces, we can go for the direct sum. Whether the statement is mentioned as subspace, whether it is mentioned, it is not mentioned. If it is mentioned, there is no need to check. They themselves say that this is a subspace. There is no need to do the checking. But here it is only generally defined. So what is the first thing you have to check? Whether it is going to be a subspace or not. Okay, you know the condition for subspace. Okay, you have to check whether W1 is a subspace and you have to check whether W2 is a subspace. Tell me whether W1 is a subspace. Yes or no? Subspace, what is the condition? It should be non-empty. Obviously, now check when I go there, but identity element 0 now. Okay, in the 2 by 2 matrix, what will be the identity element? 0, 0, 0, 0. All the 4 elements will be 0. Whether it belongs to W1? Yes or no? Question is there or no? A and B both belongs to R. Whether A and B can be 0 or not? Yes. So there will be an existing element which is of the form 0, 0, 0, 0. So it is a non-empty. Whether W2 will be a non-empty? Yes, W2 will remove the other element. Yes, so both are non-empty. What is the second condition you have to check? Alpha x plus beta y belongs to W1. Similarly, we check that alpha x plus beta y belongs to W2. If this condition is satisfied, we can say that it is a subspace. Only if it is going to be a subspace, you can find the direct sum. Otherwise, you can't define the direct sum. Is it clear, ma? So start with the solution of proof. Right? Clearly, 0 equal to 0, 0, 0, 0 belongs to W1. Belongs to W1. Therefore, W1 is non-empty. First condition is satisfied. W1 is non-empty. What is the second one you have to prove, ma? Alpha x plus beta y belongs to W1. Here instead of x and y, what you have to assume? Matrices. Two matrices A and B. So right? Let the matrix A, B belongs to W1, where alpha beta belongs to F. Alpha beta belongs to F. Therefore, alpha A plus beta B. Alpha x plus beta y. So alpha into. We assume the elements in W1. W1, what is the list of elements? Only first row is the element, second row is going to be 0. So how can you define A? A1, B1, 0, 0. Plus beta A2. How will you define B? A2, B2, 0, 0. Because both belongs to W1. So if I add both, what will be the resultant answer? No? Correct answer. Alpha A1 plus beta A2 alpha B1 plus beta B2. Second row 0, 0. So when you multiply the scalars inside and add, this will be a final answer. Whether this belongs to W1? Yes. So what is the nature of W1 elements? Only the first row should have the elements, second row should be 0. Whether it is satisfied or not? Yes. So this belongs to W1. So whether W1 is a subspace? W1 is a subspace of V. W1 is a subspace of V. What is the next one? No? W2. No need to give the proof. Just you put similarly and we will be answer. Because in a similar way we can do it. Right. Similarly, W2 is a subspace of V. Similarly, W2 is a subspace of V. Now, we have proved that both are subspace. Now we can go for the direction. What is the first condition? W1 plus W2 should be equal to V. The entire set. Being the equivalent the entire set. So, what is the entire set here now? How we define V? V is M2 of R. V நம்ம எப்படி define பண்ணிருக்கோம்? M2 of R. The set of all 2 by 2 matrices whose elements will be the real numbers. Okay, so if you add W1 and W2, your resultant answer should belong to M2 of R. If it belongs to M2 of R, then the first condition is satisfied. Okay, என்ன கொடுத்திருக்காங்க? W1 W2 ரெண்டுத்தையும் ஆட் பண்ணா அது ஃபைனல் ஆன்சர் என்னவா இருக்கும்? V ஆ இருக்கும். இங்க V ங்கற வெக்டர் ஸ்பேஸ் அவங்க என்ன சொல்லிருக்காங்க? M2 of R னா என்ன? 2 by 2 matrices. That's all. Where all the elements will be of real numbers. So இப்போ நம்ம ரெண்டுத்தையும் ஆட் பண்ணி பார்க்க போறோம். நம்ம resultant answer 2 by 2 matrix ஆ இருக்கா இல்லையான்றதை check. Okay, so right. W1 plus W2 is equal to W1 plus W2 is equal to just simply add both the matrices. W2 the elements will be of the form A, B, 0, 0. W2 the elements will be of the form 0, 0, 0. When you add both, what will be a resultant answer? It is of the 2 by 2 matrices whose elements is A, B, C. Whether it belongs to V? Yes or no? Yes. So what is V for us? M2 of R. Generalized one. What is M2 of R? Set of 2 by 2 matrices whose elements should be a real numbers. Condition is satisfied or not? Yes. So first condition is satisfied. What is the second one you have to prove? The intersection should be 0. The 0 element, that is your identity element. Okay. Whether it is obvious or not? No? Intersection is what is the meaning? Common. Okay. What is the nature of W1 elements? A, B, 0, 0. Okay, first row is the second row should be 0. What is the nature of second W2? First row should be 0 and second row should have the elements. This is the எல்லா elements ஓட nature. It will be like that one. अपने ரெண்டுக்கும் காமனா ஏதாவது இருக்குமா? Yes or no? No, nothing will be in common. ஆனா ஒரு element மட்டும் காமனா இருக்கும். அது என்னவா இருக்கும்? Identity element mark. Okay, so it will be 0, 0, 0, 0. So we have to put a result. Okay, only one element will be common. What is that one? The identity element alone. No other element will be common for them. Is it clear? So both the conditions are satisfied. Whether it is the direct sum or not? Yes. So right. Therefore, W1 direct sum W2. What is the symbol? Plus with a circle. W1 direct sum W2 is equal to M2 of R. Is equal to M2 of R. Easy or not, no? Easy. Yes. And the closed in our விஷயம் சொல்றேன்னா அது மட்டும் நல்லா புரியும். அது வர ரிசல்ட் ஆக்சன் அந்த செட்டுக்குள்ள இருக்கா இல்லையாங்கறத மட்டும் தான் நீ தெரிஞ்சுக்கணும். அந்த கான்செப்ட் தெரிஞ்சிச்சா you can give any proof whatever the questions will change. Okay, is there any doubt in this direction? Okay. Now we are going for the next concept, solving simultaneous equations, homogeneous as well as non-homogeneous. Idhula vandha nee school days la padichirukka matrix topic. You will give a system of equations. You will be checking whether it is consistent or inconsistent. Whether it is going to have a solution or no solution or infinite number of solution. In matrix topic, all those things would have been discussed. At least somewhere you heard those words. I surely I know that you will not over all the concepts. At least you have heard those words or not. So, if you give a set of equations, you will check some condition and you will say that this is going not going to have a solution. This is going to have a unique solution, or this is going to have an infinite number of solutions. The same concept only, that here you are going to solve it based on our algebraic concept. But the same method of solving now, we are going to take a help of our matrices concept only. In your first semester, you study matrices, yes or no? Because your common syllabus, so everyone study matrices. Yes? Unit 1, what you discussed? Matrices. What is the main problem you have discussed? Eigenvalue and eigenvector there. 16 mark question. Orthogonal transformation. Okay, that would have taken some elementary transformations and you have converted either to a diagonal matrix or you have converted to an identity matrix. You remember? The original matrix and the matrix steps convert பண்ணுற ஃபைனலாக அது ஒரு diagonal matrix கொண்டு வரும். அந்த diagonal matrix தான் அந்த canonical formula இருக்குங்க அதுதா. That matrix elementary transformations. ஒரு ரோல இருந்து இன்னொரு ரோவை எப்படி ஜீரோவா மாத்துறதுக்கு ஒரு ஸ்டெப்ஸ் ப்ரொசீஜர் கொடுப்பாங்க. The same thing you are going to follow here. Using those elementary transformations only, you are going to solve the given system of equations. You are going to find what are the unknown values. Okay. Can everyone do the step 1 elementary transformation? Okay. What is the step 1 you will do in that one? For example, you are given a 3 by 3 matrix. You have to convert it as a diagonal matrix. What is the first step in your elementary transformation?
Lambda.
I am not asking eigenvalue or nothing. Just a transformation alone. You are given a 3 by 3 matrix. Convert it as a diagonal matrix. Elementary transformation I never R2S transformed as elementary transformation. I am asking that steps. What is the first step you will do there? You will keep the row 1 as it is.
R2 is equal to
leave that one. Just tell me generally. You will keep the R1 row to be understood. What is the change you will make in R2 and R3?
below R1 everything should be 0.
With the help of first element of first row, you will make the first element of second row and the row to be 0. Yes or no? What is the second step you will do?
Below second row,
You will make the second row as it is. With the help of the second element of second row, you will make the second element of first row and third row to be 0. What should be the next step? You should keep the third row as it is. With the help of the third row, third element, you have to make the other third elements to be 0. If you have one more row, what will be the next step? Standard 16 mark question. Study or no? Now we are making it. Take down. Next topic. If you don't remember that one, then this problem will be difficult one. Take down system of homogeneous equations. We are going to discuss the problem both for homogeneous as well as non-homogeneous. System of homogeneous equations. Right? The system of homogeneous equations. The system of homogeneous equations is Ax is equal to 0. This 0 indicates the 0 vector, not integer value 0. That is the matrix A will be given as A11, A12, A13, etc. A1n. Second row will be A21, A22, A23, etc. A22, etc. AN1, AN2, AN3, etc. AN. It can be n or it can be m, that depends. It may be a square matrix or it may be a non-square matrix also. This is your general matrix A. X indicates the corresponding variables. So the variables may be x1, x2, etc. xn. That will be equal to right hand side will be the corresponding 0 vector, column vector. One is the right hand side, to be a homogeneous equation. You are over this matrix form. Never will have a system of equations for the matrix form. And get it in Ax equal to B ready. And I can vector. Yes, here Ax is equal to 0. All the B elements should be equal to 0. Since it is a homogeneous equation. Okay. So write next one. X equal to 0. X equal to 0 is called a trivial solution. X equal to 0 is called a trivial solution. Why it is said to be a trivial solution? Huh? X equal to 0 means what is the meaning?
0 by a.
All the unknowns are 0. What are the unknowns we assume? x1, x2, etc. xn. If all are 0, what happens to the equation? 0. Whether I can is satisfied or not. Okay. So x equal to 0 is called as a trivial solution. If x not equal to 0, then a solution non-trivial. Now majority of non-trivial solutions are clear. Okay. So right. So take down. Take down. Here. Here. The system of theorem statement. The system of homogeneous equation. The system of homogeneous equation. Ax equal to 0. Ax equal to 0. We say 0, write it in capital 0. It indicates the 0 is there. 0 has trivial solution. Has trivial solution. If and only if determinant of A not equal to 0. If and only if determinant of A not equal to 0. Next one. Second statement of theorem. The system of homogeneous equation. Homogeneous equation. Ax equal to 0. Ax equal to 0 has non-trivial solution. Has non-trivial solution if and only if determinant of A equal to 0. Determinant of A equal to 0. Okay. So for homogeneous equation, we check only this condition, that is enough. You have identified that is going to have a trivial solution or non-trivial solution. When we will have trivial solution? When determinant of A is not equal to 0. If determinant of A equal to 0, it is going to have a non-trivial solution. What is the meaning of trivial solution? All the variables will be equal to 0. Okay, non-trivial means it should be having some values. Okay, that you can solve it by using the Cramer's rule and we can get the answer. No need for any other steps. Okay, only this is the condition for homogeneous. For non-homogeneous and the separate condition. Okay, when it is said to be a homogeneous equation, the equation could come. The homogeneous and non-homogeneous, now how we identify? All the right hand side values should be equal to 0. That is, the constant coefficient should be equal to 0. Then it is a homogeneous. Otherwise, it is not a homogeneous equation. Whether this is your homogeneous equation? Yes or no? Why? Because all the constants are 0. So it is going to Okay. So when there is given a system of equations, first you check whether it is homogeneous or not homogeneous. Here a statement is given as homogeneous. If it is not given, then you have to check. Whether it is homogeneous or non homogeneous? Homogeneous. Homogeneous. So what is the condition to find the solution for homogeneous? No? First you have to check whether it is previous solution or non-previous solution. What you are supposed to find? Previous or non-previous, what is the condition? Determinant of A is 0 or not 0. Not equal to 0 means previous solution. Equal to 0 means non-previous solution. So first you have to check the value for determinant of A. Okay, we have to discuss whether it is 0 or non-zero. Okay, then we have to discuss whether it is previous or non-previous solution. But the very first step in all the problems will be is that rewrite this into the matrix form. Whether it is going to be a homogeneous or non-homogeneous, the very first step is that rewrite this into the matrix form. What is the matrix form? General form. Give me the general form. A is equal to 0. How do we rewrite the system of equations? Homogeneous means Ax equal to 0. Non-homogeneous means Ax equal to 0. So let's start the solution. The system of equation. Yes. Equivalent to. Ax equal to 0. You should not write equal, not equivalent. Equivalent to Ax equal to 0. What is matrix A now? The coefficients of the variables. What is the first row? First equation? 1, 1, 2. The coefficients in the first equation. Second row will be coefficients in the second equation. So what are the values? U minus 3 and minus 1. Third row? Minus 3, 2, into x. X will be the corresponding variable. What are we taking this here? x1, x2, x3. That is equal to the right hand side, B matrix. All the values are 0. So this is the corresponding matrix form. Ax equal to 0. Now you find determinant of A. Everyone knows the determinant, right? Find determinant of A. Find it. Find determinant. Check whether it is 0 or non-zero. What is the answer? Others? Find the determinant. Do it. Everyone knows how to expand it, right? Find the determinant. Minus. Answer minus. Because you show different answers. There should be only one right answer, no? Minus. Be careful now, this is the latest one. Okay, so determinant of A is minus 30. Whether it's 0 or non-zero? Non-zero. Not equal to 0. So trivial solution or non-trivial solution? Trivial solution. So right? 6. Determinant of A is not equal to 0. Since determinant of A is not equal to 0, comma, the system has non-trivial solution. Sorry, system has trivial solution. The system has trivial solution. The system has trivial solution. So trivial is tell me the answer for x1, x2, x3. 0. All the values should be 0. So right. Therefore, x1 equal to 0, x2 equal to 0, x3 equal to 0. No need to solve it out because it is a trivial solution. Okay. Next one. Go to the equations. x1 plus 2x2 minus x3 equal to 0. 3x1 plus x2 minus x3 equal to 0. 2x1 minus x2 equal to 0. So whether it is homogeneous or non-homogeneous? Homogeneous. Why? All the constant coefficients are 0. So right? The given system of equation. The given system of equation. Yes, homogeneous. The given system of equation is homogeneous. Right, next one. The given system of equation. The given system of equation. Yes. Equivalent to the given system of equation is equivalent to Ax equal to 0. Ax equal to 0. That is, write in matrix form. Tell me what is A? 1, 2, minus 1. Second row, A1 minus 1. Third row, 2 minus 1, 0. Because there is no x3, so it becomes 0. So what are the variables given? x1, x2, x3. And all the constants are going to be 0. So what is the next step you have to find now? Determinant of. To find it, I need a single answer. Others? Minus? Minus 0. Others? Everyone getting 0? Or any other unknown values? Anyone? Are you sure about 0? Shall we continue? So that when it's solved, we'll get determinant of A equal to 0. So determinant of A equal to 0, what is the meaning? It is going to have a non-trivial solution. So right. 6. Determinant of A equal to 0, comma, the system is having a non-trivial solution. The system is having a non-trivial solution. Okay, now we have identified the solution now. So that is a condition to check how many solution is going to exist. It will be based on the value of n minus r. N is the number of unknowns and r will be the rank of the matrix. When we combine both and check, we can say that how many solutions will be there. Okay? Make a note. Make a note. Number of linearly independent solution. Number of linearly independent solution is equal to n minus r. N minus r. Where n is the number of unknowns. R is the rank of the matrix. You all know how to find the rank of a matrix, ma? There are many ways to identify the ranks. Using determinant we can find, or using our elementary transformations we can find. Tell me, by which one you do? Since we have solved it using the determinant, we will find the rank using the determinant itself. So also we are having let's say 3 by 3 matrix. Okay, what is the determinant value for this one? 0. Since the determinant value for this one is equal to 0, the rank of the matrix is not 3. Okay, எந்த ஒரு determinant கண்டுபிடிக்கும் போது அது நான் ஜீரோ வருதோ அதுதான் உங்களோட corresponding rank. Okay, if you consider this as a 3 by 3 matrix, the determinant is 0. So rank is not 3. Now consider this as a 2 by 2 matrix. What is the 2 by 2 matrix you can choose? This one. Okay, consider this as a 2 by 2. And the minor connecting power of 2 in our also. Okay, and identify the determinant value for this one, 0 or non-zero. 0 or non-zero? Non-zero. So since this determinant value is non-zero, the rank will be equal to 2. Okay, ஒருவேளை இங்கே non-zero வந்துச்சுன்னா rank will be 3. For 3 by 3 matrix non-zero வந்துச்சு. அப்படினா what will be the rank? 3. Determinant 0 இருந்தா அந்த வேல்யூ கரெக்ட்டா இருக்கும். Determinant 0 இருந்தா மட்டுமே என்னாகும்? Determinant 0 இருந்தா கரெக்ட்டா இருக்கும். Determinant non-zero இருந்தா மட்டும்தான் அந்த m by n. It will be a 2 by 2 matrix or it will be 3 by 3. This is only for a square matrix, not for a non-square matrix. Okay, that will become a free rank. Can you understand? Yes, right? Since determinant of A equal to 0, rank of A is not equal to 3. Rank of A is not equal to 3. Now consider as a 2 by 2 like your minor. So 1, 2, 3, 1. What is the answer now? Minus 5. That is not equal to 0. Therefore, rank of A equal to 2. Since it is non-zero, rank of A is equal to 2. You got the rank now. Now check how many independent solutions will be there now. N minus r. N stands for the number of unknowns. How many unknowns are there? How many unknowns? 3 unknowns. What is the rank? 2. What is 3 minus 2? 1. So how many solutions will exist? Only one solution. So right? Since n minus r equal to 3 minus 2 equal to 1, there exists only one linearly independent solution. There exists only one linearly independent solution. We are searching for non-trivial solution, not non-zero solution. Okay. So now we have decided that, we have checked that there is only one solution. We are having 3 equations now. How will you solve? You have to find x1, x2, x3. How can you solve? What is the difference? What is the easiest way? Famous rule. Consider any 2 equations. We consider the first as a condition for trivial solution? Determinant should not be 0. Determinant is not 0 means trivial solution. So directly we write all the variables to be 0. When non-trivial solution? Determinant is equal to 0. In that case, you go for the rank to identify how many solution is going to exist. Every rank discuss பண்ணுவேன். Already I said that determinant is 0. After that, n will not be the rank. Okay, not we are going to discuss only for a square matrix here. Okay, so 3 will not be a rank. Then what you have to do? You have to check for 2 by 2 matrix. Okay, well, if it is going to be a 4 by 4 matrix, how will you solve? 4 by 4 matrix இருக்கு. Determinant of A கண்டுபிடிக்க 0 by 2. Now what is the rank? Rank is 4 or not? Not 4. Then how will you go? 3 cross 3. First 3 columns and first 3 rows. If it is not 0 means that will be the rank. If it is 0, what you will do? You have to go for 2 cross 2. Can you understand? No? Okay. These are the major steps. So the solutions for how you are going to pay. Famous rule. Easily you can get what is your unknowns. Okay, get it out. So let's stop up to this one now. Next class we start with the non-homogeneous.